So we've hit prelude.head empty list. And it's sometimes surprising for people new to Haskell that there are unsafe functions that don't really have unsafe anywhere in their name. Welcome back to another episode of Haskell from Scratch. It's been about a month now since I recorded the last episode, and you may not have noticed due to the release schedule. So I was reviewing the last episode, and we'd gotten to the point where our redo implementation now handles things atomically and takes the target to build on the command line. And if you look through DJB's site at this point, you'll probably have a hard time seeing what feature we can implement for this next based on the documents he's published. At least I did. But fortunately, I came across a paper titled Purely Top-Down Software Rebuilding by Alan Grosskurth, who actually built an implementation of redo in shell script by taking a look at some redo-style build scripts he found on DJB's FTP server. Alan also evaluated a lot of make alternatives and other systems out there, and I think the paper's an interesting read if you're really interested in that sort of thing. And I want to call out a couple parts of his paper and use those to motivate the next steps in our implementation. If you move on to section 4.1.2, you'll see that we've already covered this part, and that's atomic target rebuilding. This mimics what DJB already had published on his site. And then if you look up just one section more at section 4.1.1, you'll see the semantics of redo. And the part I'd like to focus on here is the use of default.do files. So you can see this example. If asked to rebuild hello.o, it'll first look for hello.o.do, and if that doesn't exist, it'll fall back to using default.o.do. So you can think of this as similar to GNU makes pattern matching, where you can specify that all .o files are built from .c files using these given rules. But this is perhaps a little bit simpler, and it's the next thing I'd like to implement in our implementation. So let's switch back to the source. And normally at this point I would think for a while about where to put this sort of thing, but I've done a little bit of preparation before recording, and I know that we want to go ahead and come up with a name here. And we'll do it something like redo path of the target, and that will give us the name of the script to run. So let's go ahead and define the redo path function. And what it's going to do is take a file path, which is just a type alias for a string. And so it'll take the file path of the target and give us the file path of the script that we want to use. So how is redo path going to be implemented here? Well, we already know one candidate for the script that we already have, and that is the target with .do. And so before going any further, let's go ahead and see if this is correct. And oh, right, I'm a little bit rusty already. What I was thinking of here is that we're going to have this list of options, and we want to take the first one that we have. So we'll use head to take the beginning of the list and try that again. Okay, so next we want to come up with a default.do. And the implementation in the paper uses a regular expression with sed, but I'm going to avoid regular expressions in Haskell because they're a little bit strange to use, and they really don't show up or they have alternatives in my experience. So let's take a look in GHC and look for something resembling the Unix command basename. So we have one here as part of system.filepath. Hugel comes up with the specific instances from filepath.windows and .posix, but they exist in just the system.filepath in a generic way. And so we can test this right now from GHCI. Let's try replace basename with the example from the paper, hello.o, and we'll replace it with default. and it's not in scope. Let's go ahead and add the system.filepath. And we get default.o, which is what we're looking for because we can append .do to that. So let's take a look again, this time with redo. And it's replaced to just default. And so if we think about this for a second, that means that attempting to build the target redo will look for a default.do file. And at first, I'm not sure if this is what we actually want to do, because that means that any target that doesn't have a file extension is going to look for default.do, and that doesn't really make sense. So I looked through Alan's paper, which actually has the source code of his implementation, to see what he had done. And the said expression that he gave only makes a replacement when there is an extension in the file name. So if you were to use just redo, it would come back to you with redo, meaning that the only option for target redo is redo.do. There's no possible default because there's no file extension. So let's see if we can implement this here. What we want to do is start to organize this a little bit better. We'll make a name candidates, and rather than put this in the list, since we may not have any option based on the target name, we're going to concatenate if, well, so replace base name of the target with default. But in the case where there's no base name, we don't want to do that. So if something here, then we replace the base name, else we just return an empty list. So let's take a look and just look for extension, see if there's a way to tell if a file has an extension. And there is the function hasExtension. So if hasExtension target, then we'll replace it with default. Otherwise, we're not going to return a candidate to be appended to the list of candidates, and there'll be just one. So let's take a second to compile this. First, we're going to need hasExtension. I'm sorry, these are part of filepath. Import system.filepath, hasExtension, and replace base name. And just compile things to make sure we're not getting off track. And we have an error here that is a little bit confusing to parse. And the reason for that is that strings are implemented as lists of characters. So you see expected type list of characters. You got a file path back. This is a little bit confusing, but this last part here gives us a little bit of an indication if we look at it. And what's happened is that I have made the mistake of returning a single element here in part of an if then else and a different type of element in the else statement. When we're returning a list one place, we need to return it everywhere else in that expression. So let's try that. And it compiles. So let's look back at the source, and I just realized that I have an error here. I haven't added the .do. And before we go on, I want to explain something that might not yet be intuitive for you, and that is the order of these operations and function applications here. Because you'll notice that there's two ways that this replace base name could be interpreted. Let's go ahead and take a look at them in GHCI. So we have replace base name here. I'm going to go back to using the hello.o example. And we're going to add do. And that gets us the result we want, default.o.do. And that's because this is interpreted like this. The precedence that we get is that this expression is evaluated first and then .do is appended. But another alternative is if it were evaluated like this, where the string concatenation happened first and things happen a little bit out of order here because we're replacing hello, the base name, with default.do, which gives us default.do.o. So why doesn't this happen? You may be used to the order of operators or operator precedence in other languages, and we can take a look at that in GHCI. So we'll take a look at the ++ function, and you can see that it has a fixity or preference of 5. But then what's the precedence of function application? I can't really think of any way to look this up because it's space. But it turns out that function application is the highest precedence in Haskell source. So that's why replace name will look for its arguments here, and that'll be evaluated before this string concatenation runs. And to see another example of this, if you look up at create process shell, the reason we needed to add these $signs is that if, for example, the $sign had not been here for create process, it would have taken the shell function as its first argument, and it's expecting a command specification. Shell is a function. It wouldn't fit the type, and we wouldn't be able to compile the code. Okay, so with that little aside out of the way, let's get back to this redo path selection problem. And the way our function's written right now, it's always going to return target.do because it's not actually looking at the file system to see which files are available. So let's look again to see if we have a function for this. We'll search for exist, and there is does file exist. And if you're thinking functionally, one way you might think about this is that you're going to filter with does file exist on the candidates and then take the first one that does from the list with head, which seems perfectly fine. So let's try compiling that. Does file exist part of system.directory, I believe. And we get this problem that we couldn't match type IO bool with bool. And this is one of the frustrating things about working with Haskell. I mean, it's a necessary thing to get some of the benefits, but it's frustrating that you have to use things a little bit differently when they are monads, especially the IO monad. So filter has an alternative version, filter m, which takes a monadic action and does what we need, and that's part of control.monad. And let's see, filter m. But we're still going to have a problem here because we get back the result in a monad, and so we're going to need to switch to using do notation. And let's see, we will store this as existing candidates, and then we'll return the head of that list. So let's try compiling that. So now we have another problem. And before even reading this, I realized that I didn't put the function signature into an IO file path. So let's try that. And so now this error is telling us that we have a problem further up on line 17. And that is that we can't use redo path here just in the middle of this expression because redo path is now a function that returns a value in the IO monad. So we need to go ahead and get the path here from redo path on the target, and then we can use it here. So let's try that. And finally we have something that compiles. But it's a bit frustrating when something needs to be moved into a monad that you lose some of the simplicity and ease of understanding of the notation from before. You can see now that we've had to move things up here. We've had to introduce these extra names, and names take time to think of and come up with, and you have to make sure they are not colliding with other names. And there are some ways to deal with this, some ways to get around it, and some ways to make it a little bit prettier. I'm going to save cleaning this up for the next episode and just focus on getting this implemented for now. So let's test this a little bit more. And I know a test case that's going to give our current implementation a problem just from experience. And that is what happens when we give a missing file. So we've hit prelude.have empty list. And it's sometimes surprising for people new to Haskell that there are unsafe functions that don't really have unsafe anywhere in their name. You know, sure, there's unsafe perform IO, But this is just head. I mean, what's happened? It's totally killed our program, and we really didn't have any indication ahead of time that this could be a problem. And the problem here is that head doesn't work when there's an empty list. So if we gave missing, it looks among these candidates, it doesn't find any of them in the file system, and then it tries to take head of the empty list. And this really actually points out a problem with our type signature here. Sometimes we may not get a file path back at all, so let's go ahead and make this maybe file path. You know, if the target, if there's no redo file for that target, we have to deal with that case. And so instead of head, let's go ahead and write something called safe head, which has actually been implemented by people in different libraries, or they just put it into their code. And so safe head on an empty list gives us nothing. Safe head on a list with at least one element in it gives us just the first element. And so now we're either going to get a file path or nothing at all. And so we need to update our code up here to deal with that case. So we need to look at the case of path. If we get nothing, for now, let's just throw an error. It'll stop building any targets following this target, but that's all I want to do for now. And we can deal with it more elegantly later on. So we can say no.do file found for target. Let's see, target. And if we received just path, and we need to use different names here, so we'll just say maybe path. I'm not too concerned about these names for right now. So if we got the path, then we can go ahead and do everything here. Oops, so let's fix the indentation here. And now we should have everything we need. Let's see. And we've gotten some problems. So let's just take a look at the line number of the first error here. We have, actually everything is on line 19. And rather than read the error, sometimes I'll go straight to the line that the problem is on, and I'll see immediately what the problem is. Because it can take a while to parse some of these error messages. Okay, so we've compiled redo. Let's see what happens now in the case of missing, and it gives us our error, and if not, it works. Now, unfortunately, since redo can't have a default.do file, we don't have anything to test our implementation with. So I guess now is a good time to go ahead and make a README file and try that out. We'll make the README file in Markdown format, and then we will convert it to plain text with a do file. So we've got readme.markdown, and let's not worry about filling out too much of this. We just want something to work with. So, you know, this is an implementation of redo of, let's say, DJB's redo in Haskell, and we can say something like usage redo target. And I believe that this will make the target look italic. Actually, let's go into Markdown mode here if we have it. Great. And so we need a do file for this. And we could have readme, let's see, readme.txt.do. But let's go ahead and use the opportunity to create a default.txt.do that converts with pandoc the file that we're receiving on input. And we don't actually know at this point because this is a default file. Before we knew the file, if you look at the redo.do file, we have redo.hs here. But since this is a default file, we don't actually know that we have readme.markdown. We have something.markdown, and we want to send it to, actually we want to just send it to standard out here. So it turns out that we've run across another part of our implementation that we're going to have to complete before we can proceed with testing these default.do files, and that is providing to the redo script the information on the target that's being built. So we'll take a look at that, and we'll take a look at cleaning up the code for redo.hs, specifically the kind of the ugliness we've introduced here with monad notation, in the next episode. Thanks for watching, and I'll see you next time.